Beneath the crushing clouds of Venus, where sunlight is scattered into a dim amber haze and the surface bakes under temperatures hot enough to melt lead, there exists a mystery that has captivated scientists and dreamers alike. The possibility of colossal subterranean caverns hidden beneath the planet's hostile exterior. Venus is often described as Earth's evil twin, similar in size and composition yet transformed into a world of extremes. Its thick atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid, traps heat in a runaway greenhouse effect, creating surface temperatures around 465 degrees Celsius. The pressure at the surface is more than 90 times that of Earth, equivalent to being nearly a kilometer underwater. Yet despite this seemingly uninhabitable environment, the geology of Venus hints at processes that may have carved vast underground voids. Massive caves formed by ancient volcanic activity on a scale far beyond anything seen on Earth. Imagine descending through the dense atmosphere in a reinforced probe, its outer shell glowing faintly as it resists the infernal heat. As it nears the surface, the landscape comes into view. Endless plains of solidified lava, twisted rock formations, and towering volcanic structures stretching across the horizon. Among these features are vast lava tubes, channels once filled with flowing molten rock that have since drained, leaving behind hollow tunnels. On Earth, lava tubes can stretch for kilometers, but on Venus, where gravity is slightly lower and volcanic flows were once immense and sustained, these tubes could reach staggering proportions, forming caverns large enough to swallow entire cities. The entrance to one such cave might appear as a dark, gaping pit in the Venusian terrain, a sharp contrast against the glowing orange landscape. This opening could descend steeply, shielding whatever lies beneath from the worst of the planet's extreme surface conditions. As the probe lowers into the abyss, something remarkable begins to happen. The temperature drops, the pressure stabilizes slightly, and the violent winds that scour the surface become distant echoes. Inside the cave, the environment, while still harsh, may be significantly less extreme than outside, creating pockets of relative stability that could persist for millions of years. The interior of this enormous cavern would be a world unto itself. The walls, formed from ancient basalt, would rise hundreds of meters high, their surfaces etched with the frozen memory of flowing lava. Strange mineral deposits, shaped by chemical reactions under high pressure and temperature, might shimmer faintly in the dim light of the probe's instruments. Stalactite-like formations could hang from the ceiling, though instead of being formed by water, they would be created by slow cooling and crystallization of molten rock or exotic chemical processes unique to Venus's environment. The ground beneath could be uneven and fractured, with deep fissures revealing layers of geological history stretching back billions of years. What makes these caves particularly fascinating is not just their size, but their potential as natural shelters. On the surface of Venus, any spacecraft or equipment can survive only for a short time before succumbing to the heat and pressure. However, inside these caverns, conditions might be stable enough to allow for longer missions, or even serve as the first foothold for future exploration. Scientists have speculated that such environments could provide protection from the intense radiation and corrosive atmosphere, making them the most promising locations for robotic or even human exploration on Venus. There is also a deeper, more intriguing question. Could these caves harbor signs of past or even present forms of life? While the surface of Venus is considered too extreme for life as we know it, the possibility of microbial life existing in more stable, protected environments cannot be entirely ruled out. If conditions within these caves are less severe, if temperatures are lower and chemical processes create niches of relative habitability, then they could serve as refuges where life might persist against the odds. The idea challenges our understanding of habitability and pushes the boundaries of where life could exist in the universe. Exploring such a cave would not be easy. The technology required to survive the descent alone would need to withstand conditions far beyond those on Earth. Robotic explorers would have to be designed with advanced cooling systems, pressure-resistant materials, and autonomous navigation capabilities to traverse the unpredictable terrain. Communication with the surface would be difficult, as thick rock layers could block signals, requiring innovative solutions such as relay systems or tethered probes. Every step of the mission would be a test of engineering and human ingenuity. Yet the rewards could be extraordinary. Mapping a massive Venusian cave would provide unprecedented insights into the planet's geological history, revealing how its volcanic systems evolved and how its surface was shaped over time. It could help answer fundamental questions about why Venus became so different from Earth, despite their similarities. And if any signs of life were discovered, even microscopic, it would be one of the most significant scientific breakthroughs in human history, reshaping our understanding of life's resilience and the conditions under which it can arise. In the end, the idea of a giant cave on Venus is more than just a scientific hypothesis. It is a symbol of exploration and curiosity. It reminds us that even in the most extreme and unforgiving environments, there may be hidden worlds waiting to be discovered. Beneath the blazing skies and crushing atmosphere of Venus, there could lie vast, silent chambers, ancient, mysterious, and untouched, holding secrets that have endured for billions of years.